This segment of our course deals with packing, maintenance, and safety in general with regard to reciprocating compressors. First, let's look at the packing. As you may remember, the packing was installed on the crank end of the cylinder. It is designed to prevent the pressurized gas in the compressor from leaking out of the cylinder. Most modern compressors use metallic rings for packing, since they seal most effectively. However, in some compressors, packing rings may be made of carbon or Teflon. These are used when the packing must operate without any lubricant or oil. Some older compressors use soft packing, such as asbestos or soft lead. A rough piston rod will do less damage to this type of packing than it would do to the hard metallic packing. However, asbestos or soft lead does not seal as well as metallic packing. The packing rings are made in segments, like these examples, and are held together by garter springs. The breaker rings, like the example on your left, are cut radially and are used to seal nearest the pressure. They are called B rings. The ring on the right is cut tangentially, in other words, at tangents. They are called T rings and are used to seal behind the B rings. These two types of packing rings are usually installed in pairs. We'll show you exactly what we mean. This packing box is divided by cups, each cup designed to hold 2 packing rings. The operating pressure of the compressor determines how many cups will be needed. The packing and the cups are then bolted securely in place with the packing gland and stud bolts. In most cases, the cup nearest the pressure holds 1 or more pairs of the breaker, or B rings. The other cup holds pairs of B rings and T rings arranged in pairs. The B ring is always nearest the pressure. Going from right to left in this illustration, the first cup holds 2 B rings, the second holds a B ring and a T ring, and the third and fourth cups are the same. If in doubt as to what kind of packing to use and how to arrange it, consult the manufacturer's manual for your compressor. Now let's take a look at a packing gland. As you can see, this one has connections for cooling water and lubricating oil and for a vent. The connections are usually well marked on the gland because you can't afford to confuse them during installation. The cooling water connection simply channels water to cooling jackets in the packing box, cooling the packing during operation. The oil inlet channels oil through the cups and down onto the piston rod. When new packing rings are being broken in, the packing usually requires more oil than normal to prevent it from overheating. The vent line is usually installed between the last 2 cups. It vents any gas that manages to leak through the packing from the compressor. After packing is installed, the packing gland should be pulled up lightly. Once the unit has warmed up, the gland should be tightened just enough to prevent leakage. Again, refer to the manufacturer's manual if you have any questions on packing. In some compressors, it is necessary to keep the lubrication oil in crankcase from mixing with the oil in the cylinder on the other end of the compressor. This is prevented by scraper or wiper rings installed in the distance piece, like this. Single-acting wiper rings will scrape the oil off the piston rod from only one direction. Double-acting wiper rings prevent the movement of oil in either direction on the piston rod. This type will prevent cylinder oil and crankcase oil from mixing. The wiper scrapes the oil from the piston rod, draining it back into the crankcase and the distance piece. From the distance piece, the oil is drained or sent to a sump line. In short, the wiper rings prevent oil from getting into the crankcase or out of the crankcase along the piston rod. That's all there is to it. We covered some of the safety devices and valves on this compressor during the last segment on lubrication. Most compressors will also have another safety valve installed in the discharge line before the first line valve. Since this is a positive displacement compressor, it is very important that a safety valve be installed. In case someone should close this line valve by mistake during the operation of the compressor. Let's suppose that this line valve is accidentally closed while the compressor is operating. One of two things will happen. Either the compressor will overload, or the compressor or part of the piping will blow up. You can see how dangerous this could be, especially if an explosive gas was being compressed in the compressor. Since this is true, safety valves or rupture discs are installed to prevent an accident from turning into a disaster. A rupture disc will simply rupture, or blow out if the pressure gets too high, thereby relieving the excessive pressure in the compressor. Since the gas is released into the atmosphere, this would obviously not be used for volatile or other dangerous gases. If the compressor is handling a dangerous gas, this safety valve would pop, releasing the excessive pressure to a flare line where it would be burned off. Just remember that the rupture discs, or safety valves, must be set to open when the discharge line pressure reaches the maximum safe working pressure of the compressor cylinder. In other words, the safety valves should be open before any damage is done to the compressor. There are a number of safety devices built into reciprocating compressors, since there is always the possibility of danger. If the compressor is handling a dangerous gas, you would automatically know that you must be careful. However, even a compressor handling air is potentially explosive. Almost any air compression system has a fire triangle. The triangle consists of oxygen, fuel, and an ignition source. The first side is oxygen. Any compressor handling air has oxygen. Oil used to lubricate the compressor is a type of fuel, and the oil and its vapor will burn. This means that two sides of the triangle are always there. All that's left is ignition. It could come from any spark, or even overheating due to poor maintenance or some other reason. This is one reason that maintenance of compressors is so important. Make sure that your compressor is operating correctly at all times. The bearings must be in good shape, with proper clearances. The oil lubricating the bearings should be clean, and there must be enough of it. Oil filters should be cleaned or changed periodically. This is one reason why compressors shut down automatically if the oil pressure drops. All clearances must meet specifications, including the crosshead in the crosshead guides. And the piston in the cylinder. Not enough clearances destroys the oil film, creates friction, and generates heat. That heat could provide the third side, the ignition, of your fire triangle. If repair of your compressor is necessary, consult the manufacturer's manual to be sure you know what you're doing. Just because you have worked on one compressor doesn't make you an expert on the next one. Don't use makeshift parts or repaired parts that don't meet specifications. This is an instant invitation to trouble. And remember, always be sure to install repaired or replaced parts correctly. If you install a valve backwards, your compressor could overheat or even blow up. If you are not sure what to do, consult the manufacturer's manual. If you don't understand it, ask your supervisor. That concludes our course on reciprocating compressors. Remember, the compressor we have shown you is a general example. It is designed to give you a working knowledge of compressors, their parts, and their function. You should now have little trouble in understanding any reciprocating compressor you're required to work on. We have some questions for you in this segment. Please turn to exercise number 6 in your workbook.